continue this sheet, first couple generic questions here. In this problem, 3 times x equals 0. What can x be for this to be true?
0.
Can it be anything else? No. Why? Good. Anything times 0 is 0, right? So whenever we have a problem equal to 0, we know one of those two factors has to be 0. What about if you had this? What can x be?
Anything.
Could be anything. Could it be negative? Positive? Fraction? Decimal? Yeah, it can be anything. There's infinite solutions for x here because 0 times anything is 0. Okay? So when things are set up to equal 0, it makes it really easy for us, right? We call this the zero product property. There at the bottom of the page, it says the zero product property says that if the answer to a multiplication problem is 0, then at least one of the factors must be 0. In other words, it's impossible to get an answer of 0 to a multiplication problem if at least one of the numbers is not 0. Okay? So flip over to this back page, and you'll notice here I have looks like a foiling problem. It's two binomials being multiplied, right? X minus 3 times x plus 4, and it's equal to 0. Remember, this is a multiplication problem. The multiplication is right here, the two parentheses times each other, right? I want to know what are the answers that x could be so that when you plug in x, you get an answer of 0. Remember, this is a multiplication problem, so only one of these things, either this set of parentheses or this set of parentheses, has to equal 0, and then the whole thing 0. So what's one answer? Yeah, George?
Plus 3.
Yeah, positive 3, right? So if I said x was 3, you would plug that in here, and you would get 3 minus 3 times 3 plus 4 equals 0. Well, this part's 0. And I could keep doing the work, but do I even care this is 7? I don't even care what that is, because I know since this part is 0, 0 times whatever this is going to be 0, right? So that's one solution, because that's what makes this set of parentheses equal to 0, right? What would make the other set of parentheses equal to 0?
Minus 4.
Negative 4, right? If I plugged in negative 4 for both of these x's, it would be negative 4 minus 3 times negative 4 plus 4 would equal 0. Well, this part is 0. Again, I don't even care what this set of parentheses is, because I know when I take it times 0, it's going to be 0. It's negative 7. Okay. But then I'm going to get it equal to 0. So the other solution is x is negative 4. So how I got those, again, was I said, what does this set of parentheses have to be for x to equal 0? And then the other one was, what does this set of parentheses have to be for x to equal 0? Okay.
So do we have to put both of them? Or?
Right, because there's two correct answers to this problem. One of the answers is x could be 3, because that would make the whole thing 0. One of the answers x could be negative 4. I solved both of these equations. We did it in our head, but what I did was I added 3 to both sides, and I got x was 3. And on this one, I subtracted 4 from both sides, and got x was negative 4. We did those in our heads up here, but we knew for this set of parentheses to be 0, x had to be 3. For the other set of parentheses to be 0, x had to be negative 4. So when things are equal to 0, it makes it really easy for us. We just find out when one of the factors, in this case the factors are binomials, are equal to 0. Okay. So questions on that one to start with? All right, here I have a binomial times a binomial. Again, it's a multiplication problem. So if one of these binomials is equal to 0, the whole thing's equal to 0, which is what I want. Okay. Well, this one's pretty straightforward. What would x have to be for this set of parentheses equal 0? Negative 6. There's one answer. Again, I don't even care what happens when I plug in negative 6 here, because I know when I plug it in here, it's going to be 0. And 0 times whatever this set of parentheses would be 0. Yeah, we could probably do it in our head. Let's say for some reason we were blanking out and we couldn't figure out that it was negative 4. Okay. Well, we want 2x plus 8 equal to 0, right? Because if 2x plus 8, if this set of parentheses is equal to 0, then the whole thing is going to be equal to 0. And then we know how to solve these equations, right? To get x by itself, we're going to subtract the 8 over. We would get 2x equals negative 8. We would divide both sides by 2. And we would get x is negative 4. So these are our two solutions to this equation. X can be negative 6 because then this would be 0, or x could be negative 4 because then that set would be 0. Things are equal to 0 makes it very easy because just one of the factors has to be 0. Yes. One answer is going to be when this set of parentheses equals 0, right? Because if that equals 0, I don't even care what this is, the whole thing's going to be 0. So one answer is when 2y minus 5 equals 0. Okay. And I can solve that. Move the 5 over the other side by adding it. I get 2y equals positive 5, divide both sides by 2. So I would just leave it as 5 halves. If you want to make it 2 and half, you can. I would just leave it as that. So one answer is 5 over 2. The other answer is when this set of parentheses equals 0. Because if this set of parentheses equals 0, I don't care what this is, the whole thing would be 0. So that's when 4y plus 4 equals 0. Right. Subtract 4 from both sides. I get 4y equals negative 4. Divide both sides by 4. And the other answer is y is negative 1. If I want to check my answer, I plug it in. 4 times negative 1 is negative 4, plus 4 is 0. I don't care what this is because 0 times anything is 0. So those are my two solutions to this equation. Yeah, here, okay, it's not a multiplication problem, it's a subtraction problem, right? It's a monomial minus monomial. Earlier we were doing binomial times a binomial. I would like to make it a multiplication problem because then I could figure out if one factor is 0, the whole thing is 0. If another factor is 0, the whole thing is 0. But a general rule to remember is that we always want to look to bring out a GCF. Okay? In every problem we do, I want you to see if you can bring out a GCF. Okay? So meaning, what's the GCF between these two binomials? Just an x, right? So let's bring out an x and rewrite what's left over. I brought out one of these x's, so I'm left with one here. And I brought out the x there, so I'm just left with minus 7. Okay. Again, if you remultiplied this back in, you would get x squared minus 7x. So a general rule is always look for a GCF first. Always see if you can bring out a GCF. It's going to make problems a lot easier. Okay. It's now a multiplication problem, right? There's my multiplication. It's x times x minus 7. So if this set of parentheses is equal to 0, I don't even care what this is because it's going to be 0. So what's x have to be for this set of parentheses equals 0? 7, right? Because if I plugged in 7, it would be 7 times 7 minus 7, which is 0. 7 times 0 is 0. And then don't overthink this, but what would x have to be for that to equal 0? Just 0, right? If x was 0, I would get 0 times 0 minus 7. Well, 0 times negative 7 is 0. That's my other answer. Let's say, all we did was we rearranged this problem. We just made it really easy on ourselves. Let's go back up to this one and let's plug in 0 and 7. If I plugged in 0, I would get 0 squared minus 7 times 0. Is that 0? 0 squared is 0, minus 0 is 0, right? If I plugged in 7, I would get 49 minus 7 times 7. 7 squared is 49. Is 49 minus 49 0? Yep, that works. Okay. So that's how we solve that problem. We pull out a GCF. We found out when is this factor equal to 0, when is this binomial factor equal to 0. So some of us had the correct answer. Right. What does x have to be for this factor to be 0? 0, because 2 times 0 is 0. So one answer is x is 0. The other answer, what does x have to be for this binomial to equal 0? Negative 9. So those are my two solutions to this problem. 0 or negative 9. Both of those work. Okay. To solve this. Now, what's different about this problem than the previous ones? Doesn't equal 0. Remember we said making it equal to 0 makes our life a lot easier. So let's just move this over to the other side and we'll be left with 0 on the right. Okay. So let's subtract 5x from both sides. I'm going to have x squared minus 5x. I just rewrote this problem. Remember, I can't subtract those because they're not like terms, so I'm just going to write it out. Equals 0. Okay. So I rearranged the problem to look like that. Another general rule is anytime we can bring out a GCF, we want to do that. Anytime we can pull out a GCF and rewrite what's left, it's going to make it a lot easier. So what's the GCF between these two? Just an x, right? So I'm going to bring out a GCF. I'm left with x minus 5 when I bring that out. It's now a multiplication problem, which is good because the multiplication problem when it equals 0 is really simple. Okay. Let's look at the first factor, this monomial, this x. What does that have to be for the whole thing to be 0? Just 0. If that's 0, I don't care what this is because 0 times whatever this parenthesis is going to be 0. The second group here, what does x have to be for that set of parentheses equal 0? 5. Again, that would make this set of parentheses 0. I don't care what this would be. It'd be 5. But it'd be times 0. So my two solutions to that problem are 0 and 5. Again, if I went back to the original problem and plugged it in, is 0 squared equal to 5 times 0? Yeah, that's 0, right? And is 25 equal to 5 times 5? Yep, that's 25. So those are the two solutions. But setting it equal to 0 made it a lot easier.